Welcome to G Fun Facts Online, where we dive into the science that's shaping our future. Today, we're talking about speed. Not just fast, but faster than sound fast. Imagine boarding a plane in New York and landing in London just 3.5 hours later. That's less time than it takes to watch a couple of movies. This isn't a fantasy from a 50-year-old movie. It's the future of air travel, and it's closer than you think. For more than 2 decades, the world has been without commercial supersonic flight. The last Concorde, a beautiful, needle-nosed marvel of engineering, took its final bow in 2003, closing a chapter on ultra-fast travel. But the roar of the sonic boom is about to make a comeback. A new generation of supersonic aircraft is on the horizon, built not just on nostalgia, but on a foundation of incredible new science and engineering, designed to conquer the very problems that grounded the last generation. So, how are we going to break the sound barrier all over again, and this time, do it right? At the very heart of this entire challenge is a concept you've probably heard of, the sound barrier. But what is it really? It's not a physical wall in the sky. It's a wall of physics. When an airplane flies, it pushes air out of the way, creating pressure waves that travel away from it at the speed of sound. Think of it like a boat moving through water, creating a V-shaped wake behind it. At normal, subsonic speeds, these pressure waves travel out ahead of the plane, essentially giving the air in front a heads up that something is coming and it needs to move. But as the aircraft accelerates and gets closer and closer to the speed of sound, which is about 767 miles per hour at sea level, it starts to catch up to its own warning signals. The pressure waves can no longer get out of the way in time. They begin to pile up, compressing in front of the aircraft like a massive invisible traffic jam. This pileup creates a huge amount of aerodynamic drag, a force that pilots back in the day described as hitting a barrier. The moment the aircraft pushes through and surpasses Mach 1, the speed of sound, it outruns this compressed wall of air. These waves, which were once stacked up in front, now coalesce and trail behind the aircraft in the shape of a massive cone. This cone is a single, highly compressed shockwave, and when that shockwave passes over us on the ground, we hear and feel it as a sonic boom, a thunderous, startling noise that can rattle windows and, in some cases, even cause damage. This sonic boom was the Concorde's Achilles heel. It was so disruptive that supersonic flight was banned over most landmasses. This severely limited the Concorde's routes, restricting it mostly to transatlantic flights over the ocean, where nobody would be disturbed. For any new supersonic jet to be commercially viable and truly connect the globe, it can't just be fast. It has to be quiet. Taming the boom isn't just a goal. It's the absolute key to unlocking the future of flight. And this is where NASA steps in. Leading the charge is NASA's X-59 Quiet Supersonic Technology Aircraft, or QASST for short. This isn't a prototype for a passenger plane. Think of it as a research vehicle, a technology demonstrator, built for one specific purpose: to prove that you can fly supersonic without the deafening boom. Developed with Lockheed Martin's legendary Skunk Works, the team behind some of history's most advanced aircraft, the X-59 looks like something straight out of science fiction. It's incredibly long and slender, with a sharply pointed nose that makes up almost a third of its length. This unique shape is the secret to its quiet performance. Instead of generating one massive, powerful shockwave like the Concorde did, the X-59's design is meticulously engineered to break up that pressure buildup. It creates a series of smaller, much weaker shockwaves. Because these waves are separated and less intense, they don't merge into one giant boom as they travel to the ground. The result, NASA hopes, will be a sound no louder than a car door closing a few yards away, a gentle thump rather than a startling boom. The plan, known as the Quest mission, is to fly the X-59 over several U.S. cities and collect real-world data on how people on the ground perceive this quieter sound. This data will then be presented to regulators like the FAA, with the goal of overturning that decades-old ban on commercial supersonic flight over land. The X-59 has already passed critical tests and fired up its engine, with its first flight anticipated in 2025. While NASA is laying the scientific groundwork, private companies are already racing to build the planes that will carry us into this new era. The frontrunner is a company called Boom Supersonic, with its flagship airliner, the Overture. The Overture is designed to carry between 64 and 80 passengers at a cruising speed of Mach 1.7. This isn't just a concept on a computer screen. Major airlines like United and American Airlines have already placed significant orders and pre-orders, signaling huge confidence in this technology. In June 2024, Boom completed construction of its massive Overture Superfactory in Greensboro, North Carolina. This came after the successful flight tests of its 1/3 scale demonstrator aircraft, the XB-1, which broke the sound barrier for the first time in March 2024. Boom is now on track to get the first full-scale engine for the Overture running by late 2025, with the goal of having passengers flying faster than sound by 2029. But here's where it gets even more interesting. Data from the XB-1 supersonic flights revealed something incredible. Under certain atmospheric conditions, a phenomenon known as Mach cutoff can occur, where the sonic boom actually dissipates before it reaches the ground. Boom Supersonic is now exploring what they call boomless cruise. If they can prove that Overture can fly over land at supersonic speeds under these conditions without creating a disruptive noise, it would dramatically expand its potential routes, revolutionizing global travel far beyond just ocean crossings. Of course, the path to a new supersonic era is filled with immense challenges. Beyond the sonic boom, engineers have to solve a host of other complex problems. Supersonic aircraft need to be incredibly sleek and narrow, with swept-back wings to minimize drag at high speeds. But moving that fast creates an enormous amount of friction with air molecules, which can heat the skin of the aircraft to hundreds of degrees. This requires advanced, heat-resistant materials like titanium alloys and ceramic composites that are both strong and lightweight. Then there are the engines. They need to be powerful enough for supersonic cruise, but also operate efficiently and quietly during subsonic takeoff and landing. Crucially, new designs are avoiding the fuel-guzzling afterburners that the Concorde relied on, which will reduce noise and improve efficiency. This brings us to the biggest hurdle of all in the 21st century, the environmental impact. Supersonic flight has always been expensive due to high fuel consumption. While new designs aim to be far more efficient than the Concorde, they will still burn more fuel per passenger than a modern subsonic jet. And the issue goes beyond just fuel. Supersonic jets fly much higher than conventional planes, up in the stratosphere. Emissions at this altitude, particularly nitrogen oxides and water vapor, can have a more damaging effect on the ozone layer and the climate. The industry's proposed solution is sustainable aviation fuel, or SAF. Overture, for example, is being designed from the ground up to run on 100% SAF, which can significantly reduce its carbon footprint. However, the science is still out on the non-CO2 climate impacts of high-altitude emissions. It's a complex problem that regulators and scientists are studying intensely to ensure that our need for speed doesn't come at an unacceptable environmental cost. So, where does this leave us? The convergence of government-led research like the X-59 and ambitious private companies like Boom Supersonic signals a clear message. The question is no longer if supersonic passenger travel will return, but when. The successful flights of the XB-1 demonstrator and the upcoming first flight of NASA's X-59 are not just milestones. They are tangible steps toward a new reality. The incredible innovations in aerodynamics, materials, science, and propulsion, combined with a laser focus on solving the sonic boom problem, are setting the stage for a new golden age of aviation. The dream of flying faster than the speed of sound, of shrinking our planet and bringing continents closer together, is once again within our grasp. It's a future that promises to be faster and more connected, all starting with the science of breaking the sound barrier again. Thanks for tuning in to G Fun Facts Online.